Thought I would work out some even problems from your textbook, and I've assigned some odds for homework or for your assignment today. So let's kind of go through and do these. On this one, you might want to again think of, well, let's just do the power rule in reverse. So for the antiderivative, you're going to add a power, so we get x to the minus 1, and then you're going to divide by the new power, so dividing by -1, which just makes that a minus. And then you want to make sure that you remember your plus a constant. So that one's done. These are not substitution. These are just some straightforward ones, and you have a few problems to do like that. On this next one, you just have to remember, now this is the same, remember, they kind of put the dt on the top, but it's the same as having this. And this is one you might have to look up on your Calculus for Dummies paper because you might not remember that this is actually just inverse tangent. So it's going to be inverse tangent of t plus a constant. Okay, and I'll be honest with you on the inverse trig functions. I know with the sine and the cosine, you're having that square root in the bottom, but on these, I have to look them up. So sometimes it doesn't just pop into my head, but you want to at least, yeah. So just have your Calculus for Dummies paper handy so you can do those. On number 6, you're just going to do the antiderivative of each part. So the antiderivative of 2e to the x is just 2e to the x. The antiderivative of secant x tangent x is just secant x. So remember, the derivative of secant x is secant x tangent x. And then this is x to the 1/2, so you increase the power by 1 and divide by the new power, which means you would multiply by 2/3, and then we have plus a constant. So these are just the antiderivatives. Don't forget your plus a constant. So that's what's different about these, because they are indefinite integrals, so you cannot evaluate them and get an answer, or get just a numerical answer. So don't forget your plus a constant. All right, skipping ahead on number 18, you are doing the u substitution, and in this kind of center section, they tell you what to use for u. So if u equals 2x squared, then du equals 4x dx. And then you look over here, and you don't have a 4x dx, you have an x dx. So we're going to divide by 4, so I get 1/4 du equals x dx. So now I have it set up to make my substitution. Instead of an x dx, I'm going to have a 1/4 du. If you want, you can put the 1/4 out front. And we're going to have cosine u. So here's what we're evaluating. So when we do that, we're going to have 1/4 cosine. The antiderivative of cosine is sine plus a constant. And then now we remember to put back the u. So we get 1/4 sine 2x squared plus a constant for our answer. All right, number 22, again, they tell us what to use for u. So I'm going, and this is in terms of r, so we're going to have du dr. So, and remember, this is kind of like, I'll do the intermediate step. That would be 0, and then we'd have -3r squared. So then we have du equals -3r squared dr. All right, well, we have a 9r squared dr. So what you can do is you can actually multiply. Think about what would I need to do to get this to be a 9. You'd multiply by a -3. So multiply this by a -3. So I get -3 du equals 9r squared dr. Because now I can just replace the 9r squared dr with -3 du. So over here, now I've got, when I replace that, I'm going to have a -3 du over the square root of u. So if you want to kind of clean that up and put it with exponents, we're going to have -3 u to the -1/2 du. Okay, u to the 1/2, but it's on the bottom, so u to the negative 1/2. Now we do the antiderivative, which means I'm going to raise the power by 1, making that a positive 1/2. Divide by the new power. So dividing by 1/2 is like multiplying by 2. So I'll have a negative 6 right here, plus a constant, and replace my u with 1 minus r squared. So I get negative 6. And here we'll have the square root of 1 minus r cubed plus a constant. And it really wouldn't matter if you left it as 1 minus r cubed and then that raised to the 1/2 power. That would be okay as well. All right. Next. So on this one now, we've got, for this section, notice they don't tell you what to use for u, so you have to decide. Well, we know that the derivative of tangent is secant squared. So I have a secant squared here. So then I'm going to let u be x plus 2 because du is just dx. So then I can replace this with secant squared u du. So this one's actually a little bit easier to work with because the antiderivative of secant squared u would just be tangent u plus a constant. So now replace the u, so we get tangent x plus 2 plus a constant, and that would be your answer. Okay? On number 30. Okay, this one's a little tricky. You probably don't like to hear me say that. Because think about what this means when you have sine x and it's raised to a negative power. So sine x to the negative 2 is 1 over sine x squared. Okay, well, think about what is the reciprocal of sine. Remember that 1 over sine x is equal to cosecant x, because that's the reciprocal function for sine. So what I can think of this as, because if I have 1 over sine x squared, that's just cosecant squared x. So if I have this, that's just equal to cosecant squared x. Okay, remember that when I have cosecant squared x, that's the same as cosecant x quantity squared. So like this right here that I wrote with this in this terminology, it's the same as this. So it's just a shortcut to not need the parentheses, you put the 2 here. So I'm going to think of this as the integral of 3, and I'm going to replace this sine x to the negative 2 with a cosecant squared x dx. Now, I know that, and this is kind of how I remember for cosecant, I know that the derivative of tangent is secant squared x. So then that helps me remember that the derivative of cotangent, and it's the opposite. So this is true. And the only way I can memorize this, I have this memorized, and then I know this relationship, but I always have to think about this in order to get this. So then if I want the antiderivative of cosecant squared x, it's going to be negative cotangent x. So I'm going to end up with negative 3 cotangent squared x. Oh, not squared though. Cotangent x plus a constant. So notice I did not use substitution at all. So I didn't use the u substitution, but I used a trig identity to kind of rewrite that. And so you might look at that and go, well, how would you even think to do that? Because my problem was looking here, I thought, wait a minute, I've got sine, but how am I, but I don't have the derivative of sine is cosine, and I don't have any cosine out here to do the whole u and du thing. So that's what made me think. So that can happen in some situations. So that one's a little tricky. Okay, that should make this one a little easier though, because we just reviewed the derivative of cotangent is negative cosecant. So you do need to remember that. The derivative of cotangent x is negative cosecant squared x. So what we're going to do there then, we're going to let u equal cotangent x, because then du equals negative cosecant squared x dx. So we could think of it, because we're replacing the cosecant squared x dx, so multiply both sides by a -1. So then my integral becomes u to the 1/2. We're going to have a minus. I'm just going to put it out front, du. All right, so again, that was square root of cotangent x, so it's just to the 1/2 power when I substitute that in. So then the antiderivative is going to be u to the 3/2, because you increase the power by 1. Divide by the new power, or multiply by 2/3, make it a negative, plus a constant. Replace your u with what it was, cotangent x, so I get negative 2/3. Cotangent, you can put a 3/2 here. I'm going to do it like this, to the 3/2 power plus a constant. Okay, so that's what you would do on a problem like that. So you can see how these you need to know. Number 34, notice we have tangent and we have secant squared. Now, this one's kind of an interesting problem, because the derivative of secant is secant times tangent, which we also have here. The derivative of tangent is secant squared, so I'm pretty sure this is a problem that could kind of work either way, but we'll do it a particular way. I'll do it just one of the ways. So I'm going to let u equal tangent x over 2. Okay, so then we would have, and I'm going to do this in 2 steps, so du dx would be secant squared x over 2, and then because of the chain rule, we have to multiply by the derivative of x over 2, which is 1/2. So then we get du equals 1/2 secant squared x over 2 dx, but I don't have a 1/2 up here, so multiply both sides by 2 and we get 2 du equals secant squared x over 2 dx. So now we have it set up to just do our substitution. So we're going to have the integral. This is going to be, remember, u is tangent of x over 2, so then this is that to the 7th power. So we get u to the 7th power, and then we have a 2 du that we're going to replace this with. So I'm going to put the 2 out front, du. Now I'm ready to do the antiderivative. So we have a 2. This is going to be u to the 8th divided by the new power. So I get u to the 8th over 4. And now I'm going to replace my u with tangent. I'm going to make this a 1/4 too. So we're going to have 1/4, and we'll have tangent to the 8th power x over 2 plus a constant. And I'm choosing to write it in that format like they gave it to us in. So that would be our answer. Okay, next problem. Now, here's the other little trick too, because here we have the situation where you know the derivative of cosine is negative sine and the derivative of sine is cosine, so which one do you choose to be u? Well, you want a couple things to look for. We don't want du to be in the denominator, so that's one hint. But u can be in the denominator. So that's one hint that I would want to use this 2 plus sine t as u. Another hint is that this is kind of an inside function because it's inside being raised to the second power, and it's easier to deal with if we have that be u. So that's how you kind of tell when you have two choices where you're not really sure. So I'm going to let u equal 2 plus sine t. So then du would equal cosine t dt. And I have a cosine t dt right here that I'll be able to replace. I can actually leave the 6 there. It won't matter. So then when I replace this, I'm going to have 6 over u squared, and we'll have du. All right, so that means I have the integral of 6u to the minus 2 du. So we'll have a 6. I'm going to raise the power by 1, which means it makes it a negative 1. Divide by the new power, which would be a negative 1, which just makes this a minus 6, plus a constant. And then now replace with the 2 plus sine t. So we get negative 6. And we're going to have, actually I'm going to do this and just write it negative 6 over 2 plus sine t plus a constant. Okay? I was just going to say, are there any questions on that? Like I would in class, but you'll have to send me a message. Okay, so notice the difference here. This is a definite integral. So remember, this is the one where we're going to be changing our limits. So we still have to decide the value of u. So again, notice the inside function. So I'm going to let u equal 1 minus r squared. So then du equals negative 2r dr. And I have an r there, rdr, so we're good on that. Actually, I want to just solve for rdr, so I'm going to divide. I'm going to have a negative 1/2 du equals r dr. Now, because when I substitute, I'm going to use new limits. So I'm going to go ahead and do that now, which means I need to evaluate u of 0, which means plug a 0 in here. So I get 1 minus 0 is 1. And then I need to evaluate u of 1. So I plug, that's the upper limit, because now I know the lower limit is 1. So when I plug in a 1, I get 1 minus 1, which is 0. So my upper limit is 0. Okay, so these are the new limits that I get. So now I can replace, and I'm going to have let's see, we have a negative 1/2. I'm going to bring that out here, and my rdr becomes the du, and I'm going to have u to the 1/2 du. So now we're going to evaluate this. So we're going to have u to the 3/2 when we add that, and then we're going to have a 2/3 here. We're actually going to be able to evaluate this one. We don't have to go back to the original values because we changed our limits. So here if we plug in a 0, we get 0. And if we plug in a 1 to the 3/2 is 1. 1 times 2/3 is 2/3. So we have negative 1/2 times negative 2/3, and we get a positive 1/3, and that's our answer. So on these, you can actually get an answer to them. Remember don't forget to find the new limits when you do that. Next problem we have here, also a definite integral. And this time we also have that situation with sine and cosine, but notice how this is kind of embedded there. So I'm going to let u equal 4 plus 3 sine x. So du equals, that's going to be 0. We get 3 cosine x dx. Look up here what we have. So I want to get rid of this 3, so I'm going to have 1/3 du. equals cosine x dx. Now I want to find my new limits. So u of negative pi is going to give me my lower limit. So I need to evaluate 4 plus 3 sine of negative pi. So thinking of a unit circle, negative pi is over here. So it's going this way. So the sine value is 0 because remember it's the ordered pair. The sine is the y value of the ordered pair, so we get a 0. 4 plus 0, so we get 4. And if you substitute in the upper limit here, so when we plug in a pi, we still get 0. So we have 4 plus 3 sine pi. Oh, this is going to be interesting. Equals 4. So my new limits, I have a 4 and a 4. Do you see what's going to happen? It doesn't even matter. It doesn't even matter what this is. Look, 4 and 4. My answer is going to be 0 because when the limits of integration match, then you're going to get 0 for an answer. So let me tell you what it would have been, just in case, because that's not always going to be the case. So let me just show you what you would have substituted. So we would be substituting in place of the, we'd have a 1/3 out here, and this was in the denominator, so it's u to the 1/2 and du. So this would be my integral, and then I would do the antiderivative, but hopefully you don't go through all that extra work. You'd still get 0 if you did it, but just notice that because that is a good thing. Okay, this one. Kind of an interesting problem when you look here, because when you have a trig function, you know that to do the antiderivative you need another trig function because that's gonna be involved in that. So there's a trick to one like this. It would be the same thing if this was just a tangent x, because you'd look and go, well, how can I do that if if I don't have somehow where I'm involving a secant? So this is what you do. You think of this as the integral from pi over 4 to 3 pi over 4 of, now remember that cotangent x we can think of as, because tangent is sine over cosine, so this is cosine over sine. So we end up with cosine x over sine x dx. So now notice that I've got a pair here. I've got this combination where I know that the derivative of sine x is cosine x. And also remember the du you want in the top. So I'm going to let u equal sine x, because then du equals cosine x dx. And I'm going to find my new limits. So u of pi over 4. So we need to know what sine of pi over 4 is. You got to know these values because there's a lot of, you would be expected to know this without a calculator. Remember, sine and cosine of pi over 4 are both the same. It's the square root of 2 over 2. And u of 3 pi over 4. So we need to know sine of 3 pi over 4. It's still going to be a root 2 over 2, but think about the quadrant that it's in. So 3 pi over 4 is a little bit less than pi, so it's quadrant 2. All students take calculus, so it's positive. Oh, seriously? Okay, I happen to pick 2 examples that, because now my limits, it's going to be the square root of 2 over 2 and the square root of 2 over 2. And then we would have, let's see, we would have u to the minus 1 du. And we could do that, but it's going to be 0 because the limits match. Okay, please do not think that all limits are going to match because they won't. But that's okay. We learned something important on this problem anyway, what you do in this case. So if you're finding an integral involving cotangent, you want to change it to cosine over sine. If you're doing an integral involving tangent, just tangent, you want to change it to sine over cosine. So that was important. So hopefully this helps you to do the problems on your homework. And you're actually going to have a couple days to get that assignment done, which, I would have given you a couple days in class as well. So let me know if you have any questions, please.